This video is going to discuss conditional probability and different types of example problems that arise when we're talking about conditional probability. So first and foremost, we need to know the notation. The notation here is going to have this vertical line in the middle, and what that vertical line is going to tell me is whatever event has been written after that, if I see this notation, this second event is what has already been given. So this is the condition that has occurred, and now I need to determine the probability of event A happening, given that event B has already happened, that's already occurred. So our first example problem, we're going to use a two-way table. This two-way table shows us different types of computers that are in a computer lab, and if they are new or if they are used. So I've given you two different problems here using my conditional notation. This first question is going to ask us to find the probability that the computer is a Mac, given that the computer is a new computer. So the first thing that I need to figure out is what I should actually be looking at in general. Because I've been given that the computer is new, the only piece of the table that I'm going to look at is the new row, because I know that that is absolutely true. So in that case, that's going to tell me that I'm going to be using these 70 computers that are new to choose from. And then out of those 70 computers that are new, how many of them are also a Mac? And that's going to go in the numerator. So that would be 30 that are new Macs out of the 70 new computers. Now for the second question, it's asking me the probability that it is a used computer, given that it is a PC. So now, I'm in the PC row, because I know that that is true. So there are 60 total PCs. How many of them are used PCs is going to go in the numerator. So that would tell me that there are 20 used PCs, giving us a probability of 20 out of 60. Now what if I give you the same table, but now throw you a word problem instead of the notation? Same idea. Look for what they tell you is given, and that's where I need to start. So in this case, I've been given that the computer is a Mac. So I'm going to highlight the piece of this table that matters to me. The Macs matter because that's what already I know to be true. That is my given statement. So there are total Macs would be 40. How many of those Macs are also new? So the probability of a computer being new, given that it is a Mac, would be 30 out of 40. Now what if I don't give you a two-way table? How would you figure it out? Well, there is an equation that we can use, a formula that's already been derived for us. Conditional probability of event A given event B is expressed as the notation we already know, and that's going to be the probability of event A and event B happening divided by the probability of event B occurring. And remember, in this case, because B comes second, B is my given. So my given probability is always going to end up in the the denominator. The probability of them happening together is going to go in the numerator. So let's look at an example problem where this is going to apply. So Mr. Jonas's homeroom. I've got 70 students that have only brown hair, 25 students that have only brown eyes, and 5 that have both brown hair and brown eyes. So the question is, given that somebody's leaving early, what's the probability that they also have brown eyes if they have brown hair? You could write this in the probability notation to help you figure out where all of your pieces of the puzzle are going to go. So if I do that, I need to figure out what has been given to us already. The student has brown hair. They're telling me that that is true. So that would be my given statement that's going to go after my given vertical line in my probability statement. And I'm looking for a student that also has brown eyes. So that's my event A. Event B is that they have brown hair. So ultimately, I need to find the students that have brown hair and the students that have brown eyes and brown hair. So my equation that we're going to set up, or my probability fraction, I can give myself some more room. In the numerator, I want the probability of brown eyes and brown hair. I'm going to abbreviate. So brown eyes and brown hair. And the denominator is the probability of a student having brown hair. Now this one is a little bit tricky because they didn't tell you the students that have brown hair. They told you the students that only have brown hair. So that tells me, if you think of this as a Venn diagram, we'll call this brown eyes, we'll call this brown hair. The 70% of those students live in this part of my Venn diagram because they only have brown hair. There are 25% of these students that only have brown eyes, and 5% of these students that have both brown hair and brown eyes. So when I go to create my probability fraction, I need to be very careful when I deal with brown hair. So let's start with the numerator first. So brown hair and brown eyes, that's where those two pieces of the circles overlap, where they happen together. So that would be the 5%. Not going to put a percentage into an equation. I always have to substitute that as a decimal. So I'm going to have 0.05 in the numerator to represent the 5% of people that have both brown hair and brown eyes. But when I look at the probability that somebody has brown hair, I need the entire brown hair circle in my Venn diagram. So it's not 70%, it's actually 75%. So the denominator is going to be 0.75. And when I go through and actually figure out the probability of that happening, I'm going to put it back into a percentage, and this would be 6.7%. Last but not least, we're going to talk about independence and conditional probability. So if my conditional probability also happens to be the exact same probability as just event A happening, we can consider those two things to be independent, and we're going to look at an example together. So the probability that you cleaned your room this morning is 60%. There's a 10% chance that your mom is upset with you. And the probability that you cleaned your room and that your mother is upset with you is 6%. So the way that I set this up is I'm going to think of event A as my mother being upset with me, and event B as me actually cleaning my room. So the way that I would write that statement, I'm going to look at the probability of my mother being upset, if I can spell upset correctly, given that I cleaned. So in my numerator, I need to find the probability of my mother being upset and I have cleaned my room in the morning, because I want to know where those two things happen together. So the probability of my mother being upset with me and the fact that I cleaned my room is this 6% that I have at the very end. So I'm going to put 0.06. And then the probability that I cleaned my room this morning, because that's my given statement, is going to go in the denominator. So I'm going to put 0.6 for 60%. So if I do this division, that's going to end up giving me 0.01, which is 10%. So this also does become 10%. So if my conditional probability of my mother being upset with me, given that I cleaned, is 10%, and there's a 10% chance that my mother is upset with me, what that tells me is because my conditional probability is also the same as my mother being upset with me, that my mother being upset and me cleaning my room are independent events. So those two things are separate from each other, and they don't affect one another. Other than that, we'll do some example problems together in class. If you have any questions about conditional probability, please make a note in the side of your notebook margin. Ask me during class, and we'll make sure that those questions all get answered.